To start off with, we take a 2.5 inch muffler pipe, about 6 inches long, and trim down the first probably 5/16 of an inch. Uh, and these things, most of these measurements aren't critical. It's just for looks. You take it down to where it's probably 30 thousandths of an inch thick or so, and you say, I haven't got a lathe. Well, you can use a Dremel tool to do the same thing. Most of the things that I do here, even though I used a lathe because I've got one, you don't need a lathe. Okay, we use a 2.5 inch hole saw to cut 3 pieces out of 1/2 inch plywood. I use the real tight plywood. A lot of people call it Baltic birch, but it's just real good quality plywood. You need 3 of these pieces. Use the 2.5 inch. I use a Lennox hole saw, but whatever you've got to work. It leaves a little rough edge around there where where the hole saw meets in the middle. Sand that down and test it to where it'll fit in the tube real nice. Muffler pipe is welded. It's got a seam in there. You may need to grind it out a little bit, but just sand it down until it fits real good. That one's a little bit snugger than it should be. I'll sand it down a little bit later. Then you need to mark out where the dowel rods are. I used 1/4 inch dowel rods for the spacers for the different segments, and so I just took a piece of paper, wrapped it around there, around the wooden disc, folded it in thirds, and used that to mark it off. Like I said, this stuff isn't critical, but you want to get it, as evenly spaced as you can. But if it's off a little bit one way or the other, it doesn't matter. And so the spacing, you'll have to just sort of judge that for yourself. You just want the battery to fit in there reasonably loose enough to where it'll slide in and out, but not so loose that it falls out between the rods. So on the particular one that I did, the spacing off the edge was 355 thousandths. But it's like I said, none of this stuff's rocket science. You can space it where you want to, and to make it fit snug, but not so snug that you have to pry the batteries or beat them out or whatever. But there I am marking it, and I'm just putting like a little scratch mark in it with a caliper. And as I mentioned, I was using 1/4 inch dowel rods, but they didn't measure 1/4 inch, so I had to use a couple of 64ths larger bit, and so there I am drilling the holes out to fit the dowel rods in. And I'm using a drill press, but you don't have to have a drill press. If you hold the drill nice and straight, you can do this with a hand drill. It's nothing super critical. This isn't rocket science. It's fake battery science. Okay, so 2 of the discs that we made need to be drilled out in the center, and the hole saw, it's a 1.3/8 hole saw, so 1.375, and the top one needs to be full, and the middle, or the next 2, the middle one and the bottom one, need a clearance hole. Here are the dowel rods, and I'll show you how it goes together. You just insert them in the top, and then the middle and the bottom slide on, and you can kind of see how it goes together. And the way the batteries go into this device, the first battery goes in positive end first, and then there's a little hinged conductor for the minus, and that's on the middle plate. Then the second battery goes in negative side first. So basically the two batteries are in parallel, and then there's another positive conductor on the bottom that's connected up to the top conductor. And so I use Type Bond 3 to glue the stuff together. I've also built some where I used CA glue, Gorilla thick gel, and then an accelerator. So that's whatever type of glue you want to use is fine, but glue the dowel rods into the top section. Now on the other sections, you need to get a good feel for where they need to be before you glue them. And so I'm not giving any dimensions on that because that will depend on the size of the screw head that you use and so forth when you're putting the thing together. So basically, you put it together, dry fit it, and then get a good feel for it before you glue it up solid. And here it shows the dowel rods are about 5 7/8 inches. So the hinged plate piece that I was talking about, I used a 1/16 of an inch welding rod for the hinge pin, and it's a piece of solid copper. You don't necessarily have to use solid copper. You can use pretty much anything that will conduct electricity. I used copper because I had some of it, and I just bent it over and then rolled it around the 1/16 of an inch welding rod, and then I bent it up to form a U shape, and that is the going to be the negative conductor. And you could, like I said, you could use a piece of a tin can for that matter, but it does need to be something that conducts electricity fairly well and something that you can solder to. I use copper because it solders well. A tin can would work just as well. It does need to be reasonably heavy. You wouldn't want to use something paper thin, but you can see how the hinge action works there. And so the hinged piece goes in the middle spacer. And so I mark that out with a pencil where the pins would go. Then use a 1/16 of an inch drill the holes out to where you can press it in. The 1/16, just so happened the welding rod is a TIG rod. The 1/16 of an inch hole drilled in the wood. It's a pretty snug fit, and so it works out fairly well. I do bend the ends over once I place it in, so there's no, even if it were loose, there's no way it could fall out. So it's a pretty decent mechanism for holding that the negative conductor in place. So here's tapping it in there with a little hammer. And once you get it in there, you can use a marker and mark the length of it so you can cut it off and mark the center dimension. So I actually put a dimple in it to where it raises it up so that it's it makes certain that it connects with the battery. Here I'm cutting the copper to length, and I used a piece of half-inch black iron pipe to put that dimple in there. And then I also cut a second piece and put a dimple on it for the other battery, because the batteries are going negative to negative. And so if you just put a dimple on one side, then you've got no mechanism to touch the other battery. And you know, more than likely it would work, but better safe than sorry. Put a dimple on both sides, and that way. And you don't have to do it with a dimple. You can put a bead of solder on your metal. I mean, you can use your own imagination as to how you do it, but it does need to be raised up a little bit, in my opinion. Okay, now I took a piece of solder and put it in the middle of the two pieces in the dimple, and held them together with some pliers, and then just applied some heat with a torch to sweat the two pieces of copper together. And I've built a number of these things, and the solder it typically doesn't make its way to the hinge pin, but you can imagine the capillary action, if it were to go that direction, would seize the hinge pin up. Um, it's happened on one of them, and all you really need to do if that occurs is heat it up and move it back and forth, and while it's cooling, keep moving it. So I'm buffing the burrs off, the rough edges of the piece we just made, and taking all the so there's sometimes a little flux gets on the outside of it. Buff that off with a wire wheel, and there you go. And see, it's you can see that it's got a dimple on both sides, and we'll put it back in the centerpiece. And as I mentioned earlier, I cut the wires out long enough to where they will fold over on the backside, so it captures the negative conductor on the center separator. And here's how it goes together. Put the first battery in, second battery in with the positive pointing up, and then that gives you a good feel for where the center is. Now, the positive conductor, and I made these pieces on the lathe. Like I said, you don't have to have a lathe to do this. You can do it with a drill and a file. A half inch. The piece I use is half-inch brass. You can use a drill, a half-inch drill, and file it down a step in it. I take it down to a quarter of an inch so it goes in the hole in the center, and I use a piece of sheet copper as a conductor to take the positive out to the edge, where I can solder the positive terminal from the opposite battery to it. Get it good and snug. And the screw that I used on these is 832. I made another one with 632, and some older batteries I've seen with 632 screws on them, but I like the 832 better. It's a little bit more substantial. And then the negative, it's not, these are not 100%, because the positive on most of these, instead of being half inch in diameter, is actually about 3/4 of an inch. But for the casual observer, these look close enough. and for the most part, the negative is actually attached to the very side of the battery, and most of them have like a little L-shaped piece that comes up. This is offset a little bit so that the muffler pipe is not conductive, or it isn't, bonded to the negative, and that way it's a lot easier to not short something out when you're putting it together. Okay, here I'm getting the final placement for the center separator. And so I placed the battery in negative side first, and then I put the hinged negative conductor down. And I'm just using a pencil to mark where the appropriate spot is, and I'm gluing that with the Gorilla Glue gel, and it gives you quite a bit of time to move it around and get it in the appropriate place. If you use thin CA, like just regular super glue or something like that, it doesn't really give you much time to work. So use the slow setting gel; you'll be a lot better off. You can also use the Type Bond 3 in this application, but you will have to wait 20 minutes or so for it to set, and really set. It's more like a few hours, but it's this is strong enough. There isn't any strain or stress on this in this area. So the final battery, I set that in there about level with the battery itself, not counting the positive nub that sticks up. And you'll see later on when we put the second positive conductor on the reason for that. But set it about flush with the outer edge of the battery, and then and glue it in just like you did the center spacer. Okay, so the the negative, the hinged negative conductor, it needs to be soldered to the outer terminal, because the negative on number 6 batteries, the outside terminal is always the negative, and so it needs to be soldered to that. The positive terminal needs to come up and go to the outermost spacer, and then that's where we'll attach those two together. So the by the nature of putting the batteries in positive first and then negative first, you basically have the two D cells in parallel. And here I am blocking your view with a soldering iron, but I use a Weller soldering iron, and just regular rosin core solder. You don't want to use acid core on it because it would it cause your terminals to corrode the wire all up and everything. But basically, it's what I mentioned earlier. You connect the center hinged conductor to the negative, and then there's a copper plate on the positive terminal at the top, and you connect it to the copper plate at the far other side. So positive on both ends, negative in the middle. So there's the positive terminal. It's another piece of sheet copper, as I mentioned before. If you don't have copper, but you can get brass. They sell brass at all the hobby stores, small sheet brass. You can actually cut it with scissors. You know, if you got a pair of heavy duty scissors, but and that would work just fine. But any conductive metal will work. So this stuff isn't, very critical that you have to obtain exactly the same stuff I had. I just happened to have a lot of sheet copper laying around, so that's what I used. And then the negative terminal at the bottom is held in by two little wood screws, and the when we place the bottom spacer in, it leaves that nub sticking out, which is it's probably 3/16 of an inch, I guess. I haven't measured it, but it gives enough space there that it puts enough tension on the batteries to hold them all in nice and firm. So I haven't had any issues with it yet, and so there's no springs or anything like that involved in the mechanism. So it feels fairly solid once you hold it. It's and I don't have an old number 6 battery. Every time I used them up, I took them apart and took the carbon out, so I don't have any of them laying around to weigh. But I guess if I cared enough about it, I could look them up. Somebody's got a weight of it someplace. But these, just by memory, feel about the same weight as the original batteries did. So there's the mechanism slid inside of the muffler pipe, and I put it just about 3/16 of an inch below the top edge where I thinned it out. And here you go, just to prove that it works. Okay, now the plywood that I use for the separators is 1/2 inch. So I measured the offset, which I said is about 3/16 of an inch, and then add the 1/4 inch to it and take a center punch and mark that. And then I start out with a 1/16 of an inch bit and drill a hole into the all the way through the metal and into the plywood, and then I follow that up with an 1/8 of an inch bit and a countersink. To countersink, I use just a standard wood screw, and I only use one wood screw to hold the thing together. There isn't any tension on it to speak of, and one screw is sufficient to get the job done. And countersink it so it's below the surface, and that holds it, pretty much holds it all together. And when I use the 1/8 inch bit, I just go through the metal. I don't go into the wood because I want the wood screw to bite in to the wood good and firm to hold it still. And this is going to be covered over with the outside cover, so you always want to do a good job and do as clean a job as you can, but it really doesn't matter because nobody's going to see this part of it anyway. And the screws that I'm using are number 4s, I believe, brass screws. It's just what I happen to have on hand. Again, none of this stuff's critical, so you don't, whatever screw you've got, whatever small screw you got, will work just fine. So I'm using Super 77. Again, it's what I had on hand. You can use any adhesive to glue the label down, and I'm using heavy chipboard for the backing, and so I just printed out the label, and a laser printer would be a lot better. I didn't have a laser printer, so I had an inkjet printer, and so that's what I used. And I used the Super 77, sprayed it down on the chipboard, then laid the label down. And I've got a rotary trimmer, so I trim the label off to the proper appropriate dimensions. And you can do a trial fit. And there's a little bit of, and so I'm not going to I'm not going to give you the dimensions of this either, but you got to kind of go by how you like the thing to look. Um, so mine overlap, and I understand before anybody mentions it, um, the original labels were bonded onto a paper tube, and so this isn't a paper tube. It's chipboard that's rolled around, and it has an overlap to it. Now, and I haven't seen every battery made. There may be some that were put together like this, but for the most part, the ones that I recall from when I was a kid, they were bonded to a paper tube, and you can make a paper tube. It's not the end of the world, but to me, it just seemed like a lot of trouble, more trouble than it was worth. And so, just to the casual observer, the overlap, they probably wouldn't even remember that they weren't made that way. And so that's the way I chose to do it. And I did not. No, for the first one, I used Super 77, and I glued the label to the entire tube. For the last few that I made, I didn't do that. I just used a few drops of the Gorilla gel, CA gel, and I just put a few drops of that on the label where it meets the tube, just to hold it in place. And then I roll that up and overlap it, and then I clamp it in place until the CA sets. And it doesn't when you put a decent amount of clamping force on it, the stuff sets fairly quickly. Now I always protect the label, and that you see I use a couple of pieces of soda pop container. I always protect the label, because if you don't, these clamps will mar the finish up. They'll make it look kind of odd, and it may not be that bad of a deal to do that, because a used battery is going to have mar marks and stuff on it anyway. But I just didn't like the way it looked, so on one that I did without putting some backing on it. So all the subsequent ones, I always put a little backing paper on there. And then after that CA sets, I used the Tight Bond 3 to put on the other side where it overlaps the paper. And I put that on with an acid brush, and just put a very thin sparing amount on it. You don't want to overdo it, because if you put too much on it, it'll squeeze out, and it'll kind of look strange. It won't look good. So I just put that down on a piece of paper, and then use the acid brush to put just a minimum amount on. And again, when you clamp this, you'll want to use the backing material so that your clamps don't mar the finish up on your label. Make sure when you're tightening it up that you get it good and snug, or otherwise it'll be all loose and won't look right. Okay, here I'm using a divider to draw a circle for the top, and just using another piece of soda pop container for the top, and I use that, but rather than just regular chipboard, because it has a printed varnished side on it, which kind of makes it a little bit more durable than just standard chipboard. Okay, here I'm trimming out the soda pop container to make the paper lid, and I chose to use a paper lid on these. Um, that's the way the ones I remember. The older ones had a pitch top. You could just as easily make a pitch top by getting some pitch and heating it up and casting it in there. In fact, the labels that I chose for a couple of these were old enough that they probably would have had that style of top on them. And I may do that. I don't have any pitch handy, or at least any that isn't in use. It's I've got some in older potted transformers and stuff like that, but that's it's in there for a reason. I'm not going to just melt it out to put in here. You can buy the stuff. It's not inordinately expensive. Okay, so I'm punching the holes in the soda pop container with a. I've got a die punch set. Um, Again, if you don't have one of these, you don't have to go out and buy one. If you they sell them at Harbor Freight. They're not inordinately expensive, but you can take a piece of pipe and sharpen it with a file and cut the holes. You can cut them with scissors, or an X-Acto knife would be an all right way to do it. So I'm actually coloring the thing in with a blue Sharpie. Uh, it comes out really close to the way the ones that I recall originally looked, and so that's how I'm coloring it out. Just rubbing over it with a Sharpie. It doesn't seem like it would look all that good, but it actually looks fairly decent once it dries. You can barely discern any, or as far as I can tell, you can't tell any like pen strokes or anything like that in it. It's sort of, since it's kind of a fiber board anyway, it sort of blends together, and so you don't really notice anything. And that's just held in by friction. I don't glue these in or anything of that nature. So there you go. Now I also use a clear coat. There's any number. This is Sprayway. There's any number of different finishes that you can put on there. You might want to test out whatever you're using. Uh, and I mask off the top of it because I didn't want it on the top, because the top shouldn't be. And it's the stuff's really not super shiny, but it puts a little bit of a gloss, a little bit of a sheen to it, uh, the way I recall the original ones looking. So this stuff dries like almost immediately. You can I've got it on this stick, so I can hold it, but it dries almost instantaneous. So uh, 5 minutes later, you can handle it. And so here we're making the bottom. Well, actually, here I'm putting the binding post on, which are just standard 832 binding post, or thumb screws, thumb nuts, whatever you want to call them. And so the bottom piece is made out of a piece of Mountain Dew container, and I go around the perimeter of it and sort of score it with a ballpoint pen. And you can see where I've made little marks around the edge, and that makes it easy to bend. And then I dampen just the outside about 3/4 of an inch, and leave the internal part dry. And I just take a damp rag and dampen that all the way around, and that makes it form a lot easier. And I have a piece of the muffler pipe cut off, uh, the 2.5 inch muffler pipe, and then I have a piece of the chipboard with the label on it, the piece that I cut off, when I trimmed it to size. I've got that glued on the outside of the muffler pipe, and so that's what I form that up around. And you just take it, and you just have to kind of use. I don't know. There's no way to really tell you exactly how I do it, but uh, I just sort of go by feel, and I push it in this plastic cup, and that sort of gives it the initial shape. And then I go back and I kind of wrinkle the edges, kind of mash them together to take it up. Like if you were doing sheet metal, it would be the operation you would call shrinking. So you take that and mash the edges together, and that sort of tightens it up and makes it cup shaped. And then finally, once I get that done, I will put it around the muffler pipe, and I will take that's a radiator hose clamp, and put that around it and tighten it down really snugly. And you'll want to leave that to dry for at least overnight. It's typically what I'll leave it overnight, and you'd be surprised with nothing other than just water and pressing that in place when it dries, it'll pretty much hold its form. It's almost like it's glued in that shape. Now sometimes it might come apart a little bit. You can go in there and put some CA on it or something like that to hold it in shape. But let that set overnight, and then I use a Sharpie, so you can tell it's a Diet Mountain Dew container. I used a Sharpie to color it just like I did the other, and there you go. Reasonable facsimile of a number 6 cell. And there's a couple of them. And I use these for my antique telephones. You could start your Cox engine with them, or any number of other, use it for ignition source on your Model T, I guess, whatever you need it for.